Alright, hello everybody, and welcome back. In this video, we're going to talk about another example of confidence intervals and using the calculator for the week to create those confidence intervals. So let's jump right into this example and hit it hard. Let's see. So, a weather club for a local high school measured the amount of snowfall in the town over the course of 32 snow days and found the average snowfall to be 4.6 inches, with a standard deviation of 1.7 inches. Okay. What would be an 80% confidence interval for the number of inches of snowfall? And then there are two sub-questions here. What is a 90% confidence interval and a 99% confidence interval? Okay. So the Weather Club has measured 32 snow days worth of snow and found that their sample mean, their sample average amount of snowfall was 4.6 inches. We want to build a confidence interval for the population mean, right? We want to be 80% confident that the population mean is within a certain range of that 4.6 inches that we found for the sample. We want to be 80% sure in this range of numbers that the Weather Club is giving out to the community. Okay, so let's plug into the calculator and see what we find. So the confidence level, first and foremost, is 80%, right? That's the confidence interval that we're building, so that's our confidence level of 0.80. Now the sample size here is 32. There were 32 snow days that year, so they measured the snow on 32 days. That's their sample. Okay, first of all, will we consider this a small or a large sample size? Small or large? Well, remember the cutoff for that is 30. Anything less than 30 is considered small. Anything 30 or larger is considered large. That helps us to determine this last block here. What are we filling in? Is it T or Z? Remember, if we have a sample that is large, we use the Z-score. If it's small, we use the T. So since this is a large sample, over 30, we use the Z-score. So we've already got our Z value, and we have to plug in the rest of the information in here in the green, so that way we can get the rest of the information in the yellow. So what is our average? This is the sample average, remember. It's the sample average because we're trying to build the confidence level, confidence interval, so that way we can make a guess about the population. We're basing everything off of a sample. So our sample mean is 4.6. Lastly, our standard deviation is 1.7. Let's take a look at what happens here. So we see that our margin of error is about 0.4 inches, 0.385 inches, which means the lower level of our confidence interval is 4.2, and the upper limit of that is 4.98, or about 5. So we are 80% confident. Let's interpret that. We are 80% confident that our population mean is somewhere between 4.2 inches of snow and 5 inches of snow. And that should make sense, right? Because 4.6 is right there in the middle. 4.2 up to 4.6 is about 0.4, which is that margin of error, and 4.6 up to 5 is 0.4, which is that margin of error. So we are 80% sure that the population mean for the average snowfall, the population average snowfall for the entire population, say for the whole district, whatever the whole population is, our population mean, we could say with 80% confidence, is somewhere between 4.2 inches and 5 inches. That's what we're saying here. We're 80% sure of that. Now, what do you think will happen when we change the confidence level to 90%, to 99%? Everything else is going to stay the same. We have the same number of samples, the same average, the same standard deviation. What do you think will happen when we change our confidence level to 90%? What do we think? What do we think is going to happen? Let's find out. Take a look. The margin of error went from about 0.4 to 0.5. Okay? We broadened our margin of error, which means now that our confidence interval has also become broader. It goes now from about 4.1 up to about 5.1. So for 90%, our interval goes from about 4.1 to 5.1. Why do you think it got broader? Why do you think our margin of error is bigger now that we have a higher level of confidence? Well, let's think about it. Everything else stays the same. Everything else stays the same. If I want to be more confident, if I want to go from 80% confident to 90% confident, I want to give myself a broader range. I want to give myself a bigger target so that way it's more likely that I'm correct, right? You could be more likely correct if you're more confident in your guesstimate, basically, right? If you say a broader range of numbers, right? To exaggerate a little bit, I would say I'm 100% sure, or 99.999% sure, that in my area there was somewhere between 0 and 100 inches of snowfall. Well, sure, that makes sense because I'm giving myself a huge range. It would be silly of me to say I'm 99.999% sure that there was somewhere between 5.75 and 5.76 inches of snowfall this year. I've given myself so little wiggle room, but I've said a 99 point blah 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 % confidence level. That doesn't make sense, right? So if I want to be, if all of my data, all of my studies, all of everything stays the same, and I just want to increase my level of confidence, that means I have to give myself a bigger target. So let's see what happens then. What do you think happens when I bump this up to 99%? Well, we probably will predict that, boom, the margin of error gets bigger, the interval gets even larger. So for 99%, our interval doesn't look huge, but it is a recognizable jump from 3.8 up to 5.4. The margin of error went from about 0.4 in the original question where it was 80% to 0.7. That's a big difference when we're talking about snowfall, right? That's an extra almost half an inch, an extra quarter of an inch that we're giving ourselves as wiggle room. Okay? So our interval gets broader the more confident we want to be if everything else stays the same. Okay? So guys, this is how we use the calculator to calculate confidence intervals, to construct confidence intervals. Check back in for more examples. I'll see you next time.